Okay, in this video we are going to look at point clouds, particles, scatterers, clone stamp 3D tool, particle paint tool, and property paint tool. My plan is to give you an initial overview of the scattering possibilities within Clarice and to show you the techniques that we will be using later in a simpler context so that you can learn them more easily. First, let's create a context. Let's call it Geo. And in this context, let's create a cube. Just click here. Let's increase the scale to 5. And let's move it up. Now let us create a new geometry point cloud. Now this point cloud, we want to set the geometry to box, which we've just created. And you can find this geometry tab right at the bottom of the point cloud's attribute. So now let's set the point count to 500. And as you can see, currently the point cloud does not match the scale of the cube. It matches this original scale of the cube that it was created at. So we can just fix this by going up here. Let's disable inherit transform, parent to box, and enable inherit transform. And now our point cloud is correct to the scale of the box. And if we move our box, our point cloud moves with it. So there are several settings within the point cloud that we will discuss. First, let's look at the point count with which we've just adjusted. We can adjust it very easily. We can also choose to decimate this value. So if we decimate at 50%, we will have the equivalent of 250 points instead of 500. In addition, we can change the distribution of the points. So by default, it is at random, so all points are randomly distributed on the surface of the cube. But we can change this to blue noise, which is quite useful, which gives us a less random and more even distribution of points, so they are more evenly scattered in relation to each other. But for now, let's just use random. So one of the main cool things about point clouds is that we can decimate the number of points in a very interesting selection of ways, and it can be very useful. So, for example, let us split our 3D viewport into 2, and here let's select Material Editor. And this is usually used to edit materials, however, it also works for point clouds as well and scatterers. The networks that you plug into decimation textures or sampling textures work the same way as the textures that you would plug into material networks. So we can, for example, decimate these points on this cube in some of the following ways. And there are a lot more, but I will show you some of the basics. For example, by clicking tab, we can access all of the different nodes available in the material editor, or we can select them from the side if we know where they are. But for now, let's click tab and type in normal map and select texture normal map. Now let's plug this into the sampling texture. So the difference between the sampling and the decimation textures is that sampling provides a mask for the point cloud, which it then samples, so it only selects the white areas of the mask in order to put the points on them. So the points only appear on the white areas of the mask from the beginning, whereas for a decimation texture, it scatters all of the points or around the surface of the cube or any geometry, and then uses the mask to delete the ones that are not in the white areas. So I would recommend using sampling texture whenever you can, because instead of creating a lot of points and then deleting some of them, you only create the ones that you need in the areas that you need. So Let's plug our normal map into the sampling texture, and you can do this by just dragging from one end of this to the sampling texture dot here. And let's also create a node called reorder. And the reorder node works like the shuffle node in Nuke, in that you can put information from different channels into each other's channels. So if I move the reorder node here, and I can see that this light is, or this line is becoming orange, which means that when I drop it, it'll join the network. I want to change the color of all of these channels to green, and green represents the normals facing in the y-axis, because X, Y, Z are GB. Y corresponds to G, so let's change all of these to G. And now all of our points are only sampled and are appearing on the top and bottom of the cube. So for example, if I want to create props on a rooftop of a building, I can easily do so with this technique. Another interesting way to do this would be to create a node called distance to UV. And first let's replace this and see how this works. So let me up the number of points so I can better see what is going on. And now in here, let us add a remap node. And this acts like curves in Photoshop. So remap and reorder are two nodes that are used quite a lot when designing these networks. So I thought it'd be nice to show to everyone watching this. So with this curve, we can adjust the strength of the distance to UV, and you can see that it samples the points based on their distance to the UV, to the edges of the UV rather, so to the edges of this cube. So now we're only having objects scattered around the edges. So if we want, for example, I don't know, plants overgrowing the edges of a temple, we can easily do so this way. But for example, we can also add an invert node, and this will invert our mask. So if we also adjust this, we are now having points only appearing in the center. So for example, if I want to scatter some props on a rooftop maybe, again, it would be, good to have them away from edges, so that kind of works. And what we can also do is multiply these masks together. So let us bring in our previous one in again, and if I just drag it back in, any node that you create here appears in your browser as well. So we bring it in here, and you can see that it has a little one beside it, means that it's connected to one other node. And if we click this, this node is also brought in. So this is our previous setup. And what we can do is create another node called texture blend. And into this one, let's plug in both this and this into the two inputs and put it in the sampling texture. And here, if I can multiply, I can add, I can do whatever with these two masks. So let's click Alt for replace, and you can see now it's combined both of the two nodes. I'm only getting points appearing away from the UVs and only on the top and bottom facing axes. Here is another trick. For example, we can also sample our points by using fractal noise, or any noise. If you type in noise, there's cellular fractal Perlin, but I like fractal. Let's use this, and let's replace sampling texture with this. And here, let's change the projection to maybe planar, or rather maybe cubic. Now let's go thinner. And let us change some of the settings here. And actually, before I do this, here's a better way to visualize what this fractal noise looks like. We can double click and see it either this way, or create a new material, matte. And in this new matte material, select the color as our fractal noise. And now if I just select my box, and here drag and drop the math material into the material slot in the material linker, and then here I can select to view my viewport in a different way. So let's select progressive rendering, and now I see the actual fractal noise on my cube. So if I, let's say, select my point cloud and just Control H to hide it, so it's not going to be in the way, I can now, let's turn this off, I can adjust the settings of this noise. So let's do this and increase the contrast, maybe even more. Yeah, let's go the whole way to 100% and maybe decrease the size. Right, so now we see our fractal noise applied to the cube. So let's just go back. Actually, let's stay here. Let's re-enable the point cloud with Shift and H. And yeah, actually, if I disable this, go back to smooth, you can see that our points are appearing only where the fractal noise is white. So that is very useful. Okay, last thing that you can do in order to decimate your textures. We can create a new scope, and then also in the material editor, click tab again, and type in scope here, and let's select texture scope. So now you see we have two. We have scope and scope 1, which is texture scope, this. And in the scope 1, let's add the other scope. And so now, for example, I can use this for, okay, first of all, I'll show you decimation texture. If I increase the size of this, yeah. So now this cube is enveloping the other cube. You can see that wherever I move the scope, it is decimating the points. So this is very useful, for example, if we have, you know, water or say altitude and we don't want trees above a certain level. And in the scope, we can scroll down and adjust the fall off in order to get a more gradual fall off of the points being decimated. So here you can see it's quite smooth. I can change it to 0. It will be very sharp. So alternatively, I can plug it into sampling texture, and it seems like it doesn't work, but all we have to do is go into the point cloud and change the geometry mode to global base. And now it's only sampling where the scope is, sort of the opposite of the decimation. So let me plug it back into the decimation, and here's, let's put this to 0. Here's a cool trick. For example, if you have a big scene with water and the sea level is something that you are changing often as you're developing your idea. So for example, instead of you having to move the scope manually every time, what you can do is create new geometry polygrid, and this will be our water. So I put it here. All I have to do now is select my scope, go up to the top, parent the polygrid, and now when I move the polygrid, the scope moves with it. So you can very easily set up a system where you have a water level, and then if you're wanting to change that, your scope will adjust and your point cloud will adjust as well. Okay, let's clean this up a little bit. So when you're working with networks, it's very easy to have your scene become quite messy, as all of these nodes here are created here as well. So let's select all of these. Invert, remount, distance, reorder, normal. Yeah, and right click and let's contextualize. And let's call this the point cloud network. Just so it's slightly more organized, I guess, for later. Okay, so now let's set up a scattering system. So let's right click here, go to new, and scatter, and click this. And in its settings, in its attributes, you will find a tab called Geometry Support. We select Geometry Support and plug in our point cloud, which will be used to scatter all of our objects on. So we select it here. And now we want to add some geometries to actually scatter on top of our box. So let's just quickly create a cube, a sphere, and a cylinder. Just default size, and let's contextualize these and call these scatter underscore geo. And in our scatterer, in the geometries tab, let's click add and scatter geo, apply, and this adds all three of those. So actually, let's go in and make them slightly smaller. Let's select all of them and click R to scale, and let's just scale them down. That's a lot more clear now. So as you can see, we have a random selection of all three objects scattered on top of our cube. So if we go again to the scatter, you can see that here we can disable or enable any of these. So you can add a lot of objects and then play around with exactly what you want. Another thing we can do is adjust the probability of having all of these objects be scattered. So at the moment they're all equal at 100%, but for example, if I select box and lower this to 10%, you can see that now most of the objects are either cylinders or spheres. So we have only 10% boxes. Okay, so let's return these numbers back to normal. And let's look at some of the other attributes you get with scatter. So for example, we can affect the scatter input mode. So what does this mean exactly? Well, currently the scatter input is set to random, but if we change it to luminance, the distribution of objects will be based on the brightness of the texture selected. So for example, if your texture is black and white, you can set one object to appear in the areas that are black and the other in the areas that are white. So for example, we will use a fractal noise, and this has areas that are black, white, and also gray. So let's go back into our point cloud network that we made earlier, and let's just select fractal noise. And as you can see, now our objects are scattered in a way that corresponds to the fractal noise that we made earlier. So for example, here, if I change their order, I can change which parts of the fractal map they appear in, based from the darkest to the lowest, or the darkest to the brightest, sorry. So for example, if we go into the fractal noise and adjust the size of it, you can see that the distribution of our geometry also changes. So again, let's illustrate this by going into progressive rendering, and let me just disable this for now so it's easier to see. Basically, whenever I change this, you can see that the distribution of the blacks, the grays, and the whites changes, and that affects our scatterer as well. And so you can achieve some really cool effects using this technique. And of course, instead of just the fractal noise, we can select any of the other things we created. So for example, let's select our maybe let's do the normal map, for which we used, I believe, the reorder, where we reordered everything to be green channel. And as you can see now, we have a black and white selection. So again, progressive render. And if I disable this, and in my PC network, I go to my material and here select the reorder. This is what I had, remember? So now what I'm getting is the first object appearing in the black areas and the last object, which is the cylinder, appearing in the white areas on the top. There is no gray, so we are getting no spheres, but for example, if I switch this round, now we get spheres on the side. So this is quite cool if you want to have a more complicated scattering setup with a lot of different factors. In addition, we can also set the scatter input mode to ID, but I will come back to that later because there is a little bit more to talk about there. So another trick to show for now is using support normals. And Cube is not the best way to show this, so let me just create a new geometry cylinder, and let's just scale this up. Put it here like this, and if we scroll to the bottom, we can make sure we have our show caps. This adds the top bit. And let's change the point cloud from box to cylinder. And we also have to adjust the settings here. So if I disable inherit transform and select cylinder and inherit transform again, now everything is scattered on the cylinder instead. So let me disable the box just for now. And as we can see, actually let's go in and here in the scattered cylinder also enable caps, looks slightly nicer. So as you can see, all of our objects are scattered on the cylinder. However, all of the rotations are currently just the same as how they were originally created. So there's no variety in that regard. So what we can do is we can go into our scatterer and go to support normals. And if I ramp this up to 100, you can see that now all of the objects' rotations are aligned with that of the normals of the cylinder. So for example, if you have a ground plane that has some hills maybe, or some mountains, and you're scattering trees on top of it, you might want to use support normals slightly, so they're all still pointing up, but they are sort of following the terrain a little bit as well. So this is very useful. So in addition, what we can do also, actually let's just show you this. There's collision mode, and basically currently all of the objects are appearing intersected with each other. They don't care about where any of the other objects are, but of course you can change this to say use bounding box, and now none of the objects will be touching. Maybe this is something you will want in your own project. It's a good option to have. So let's just keep it off for now. And the last thing to look at is all of these settings down here. So what do they all represent? Well, for example, we can affect our scatter position. So if I do this, you can see, let's just enlarge this for now. You can see that the position of all my objects is changing as I change this value. So this is position in Y. So why are some of them moving not up but sideways? And that is because they are aligned with the normals of the cylinder. So their Y-axis is aligned with the normal pointing out, and therefore they're coming outwards to the side. So let's put this back to 0. Another thing you can do is, for example, adjust the variance. So this will adjust how high up each object is. So if I do this, you can see that now some of them are moving up and some of them are undoubtedly also moving down into the cylinder, but you can add a lot of variety to where your objects are scattered this way. And for example, if I change this to 10 and change this to 5, so there is a step function. And what this allows us to do is add stepping to what values it uses from the variance. So even though the variance is allowed to be 10 meters, we only want objects to appear at steps of 5. If I change this to 2, you can see we have more rings where different objects are stepped at 2 meters each time, up to 10 meters outwards. So if I, for example, change this to a lot more points, this is a lot clearer, right? So that is a cool feature and worth playing around with, because you can get some cool ideas with it. But for now, let's disable. So what else can you do? You can play around with, of course, rotation itself. So all objects can be rotated equally, or we can influence the variance. And so if you're scattering something organic, for example trees, of course you want these to be rotated at 360 degrees, right? Because you want a lot of variety in how they are positioned, and that will make your artwork look more realistic, because it'll be less identical in terms of all of the scattering objects when it comes to comparing them to each other. And of course, you can do the same thing with scale. Scale, I find, is extremely useful, especially, with trees, of course, but also with cities. You have to be quite careful with how you do it, so you don't make buildings disproportionate to each other. But, for example, increasing the variance slightly adds a lot of variety in how your city looks. And that is a great thing to know and a great thing to play around with. And I recommend that you guys do it now before we start the actual project, just to get a little bit of an idea of how everything works. So have fun.